Binomial distribution. In this section, we're gonna learn how to solve special binomial distribution problems. So the first step in solving a binomial distribution problem is knowing what is a binomial distribution. What things encompass a binomial distribution. And it's really simple. It has to be there's certain key things it has to follow. First, you should have two possible results. It says right here, two possible results. So it's like pass fail. You flip a coin, heads tails. Even if you grab, let's say we have those like marbles we have like red, blue, green, red marbles in a bag. If my question is how many red marbles do you get, like I could get 0 red marbles, 2 red marbles, 3 red marbles. That's still binomial. It's all two results. You get a red marble, you don't get a red marble, and that's the key with binomial, right? Bi two has to have two possible results: pass fail, win lose. It's pass or fail, right? Win or lose. So two possible results. That's the first thing. Second, it has to be independent. So what this means when we do like when I was talking about the bag of marbles thing, it has to be with replacement. It can't be without replacement. So independent. Some things are automatically independent, like rolling a die or flipping a coin. Like the odds never change. But if we're talking about like other stuff, then it has to be with replacement, right? Odds have to stay the same. So odds never change. Probability never changes. So if we have those things, then we have a binomial distribution. And that means we could use a binomial distribution to solve it, which is a good thing. This means the first step is being able to identify a binomial distribution problem. I think they're pretty easy to tell. Like here's a good example of one you're going to see a lot now. When a rifle shooter Huey fires a shot, he hits the target 80% of the time. If he fires 4 shots at the target, determine probably that he has hit the target 3 times, or sometimes you might see exactly 3 times. It's a dead giveaway of binomial. So 3 times or exactly 3. Another dead giveaway hits at least 2 targets, or at most one. Or he hits the target at most 1 time. These are all like binomial type problems, right? He either hits the target or he doesn't hit the target. If you see stuff like this, it's talking about a binomial distribution. That means we're going to use the binomial distribution formula, which I'll show you in a bit. So let's do some quick examples of our favorite game show, binomial or not. Woo! Right? So real quick, let's try to figure out if these things are binomial or not binomial. The first one, a coin is tossed, it's thrown 100 times. The variable is the number of heads. Right? So all I know is the number of heads. I don't care about anything else. That's binomial. Woo! It wins. Right? If you're throwing it 100 times, throwing the coins is automatically independent. The odds never change. And all you're talking about is heads or not heads. That's all we care about. Right? So that's binomial. 100 coins are each thrown once. The variables number heads. That's pretty much the exact same situation. So yes, it's binomial also. Off to a good start. A box contains 5 blue, 3 red marbles. I draw out 5 marbles, replacing the marble each time. There's the key. I'm not sure why I said it that way, but whatever, we'll go. Right? Replace the marble each time. That means the odds are not changing. That means it's independent. Right? They're not changing the odds. And the question is the number of red marbles, right? So you have 2 options. It's either red or not red. That's also binomial. So far, we're 3 for 3. All right, so again, the key things are you only have 2 options. Selecting the first one, heads or not. Second one, heads or not. Third one, red or not. So they're all binomial. That's all we care about is red or not, right? Those other marbles, I don't care about those other marbles. It's all about is it red or not. And the second thing has to be independent, right? Coins are automatically independent. The odds never change. And this one, they're replacing the marble. So the odds are never changing, right? It's with replacement. This next one, though, right? The exact same setup, 5 blue, 3 marbles. I draw 5 marbles, but without replacement, right? That means that each time the odds lower, or the total amount in the bag lower, so it changes the probability. So this one is sadly not binomial. The way we solve this, tree diagram. I draw a tree diagram, our favorite thing ever, and then solve it. A container holds 3 red, 7 white, and 2 black marbles. The ball shows at random from the container and is not replaced. Done. Don't have to read anymore. I don't like reading anyway. Right? Not replaced means not binomial. I actually do like reading. That's just in the heat of the moment. Okay, now that we know what's binomial or what's not, let's actually talk about how to solve these problems. the way we solve these is it's a binomial distribution, which means much like a binomial expansion has to do with combination, right? So here's the big old formula, or like let's look at this right here. This is in your formula sheet. So right, let's talk about what this means. First part is right here. That just means it follows a binomial distribution. That's all that means. So if you ever see that little tilde, it says right here, it's distributed as, that just means, oh, it's a B, it means it's binomial. That's all it's telling you. So it's like, okay, this is a binomial problem. You won't see it as much, but you might see it sometimes. And that's just telling you NP, and we'll talk about what NP is in a second. But here's the formula. Right now, here's some good news and bad news. Well, first, that formula is just like a binomial expansion. It's actually not bad at all. Once you figure out your values, plug it in, done. But here's the good news, the really good news, especially for some of my students. These problems are all done on the calculator. They used to have you do by hand, but honestly not anymore. Now it's all done by calculator. Right, so you got your calculator because I'm going to do a lot of stuff today on your calculator. So before we start doing that, let's talk about what all these values mean. So there's a few variables here. There's n, and the total number of trials, so total number of trials. So like when we flip our coin 100 times, n is 100. And then you see P. P is the probability of success. Now it's very important that it's success. That means the thing you want. What's the odds of the thing you want? Because sometimes it might say, oh, odds of, you want red, but they only gave you the odds of something else. You had to like do 1 minus or some other stuff. But P is only the stuff you want. So if I want reds, what's probably getting red? If I want heads, what's probably getting heads? So P is the probability of success. Very important. It's the one you want. Now, only other thing we need here is R. R is how many do you want? So like when I flip 100 coins, do I want 5 to be heads? Do I want 10 to be heads? Do I want 15? R is the number you want. And that's all the variables we need here, right? So this is our binomial distribution. Again, that's the formula. And once you have your stuff, it's actually not that bad. You plug it in there, you plug R there, you plug your stuff in. You don't have to worry about that because like I said earlier, it's all in the handy dandy calculator. But mean, now all these things right here, right? These are binomial properties. Mean or average, right? Or expected value. As we learned, mean is expected value. So that's the average is what you expect to get. That's expected. It's not a G. It's not a Disney G, right? That's expected value. This n times P. Very, very simple. Variance, notice they give you the variance. So again, and it's not variance like in your form. Like a lot of people, the biggest mistake with this, people try to use this for everything. If it says variance, then you try to use this. No, right? The only way you find variance is square root stuff, right? Variance is bigger, so standard deviation squared is what I meant to say. You can only use this variance when it's binomial. That's why it's in this little bracket here. So only if it's binomial. Right, if it's a binomial problem, then here it goes, there's your variance. If I want you to find standard deviation, remember variance is bigger, so square root the variance, right? It's just like normal. But again, the key thing I cannot stress, this variance only works when you're doing a binomial. For everything else, you gotta remember the relationship between variance and standard deviation. So that's kind of the basic breakdown. If it's a binomial distribution, we're gonna need to find 3 things. We're gonna need to find n, total number of trials. We're going to need to find P, the probability that was the thing we want. We're going to find R, the number of stuff we want. A lot of times they give you all this, you just got to like know how to plug it in. So now let's talk a little bit more how to use our calculator to do this. Now there's 2 types of distribution we're going to talk about. Binomial PDF and binomial CDF. And we're going to do this all, again, we're going to do this all on our calculator. Let me talk about PDF first. PDF means exactly. So anytime they want, oh, it's probably getting exactly 3 heads, or exactly 4, or it's probably getting 2 red, right? A certain number, an exact number. This is our binomial probability density function. So that's the only time, again, you only use this when it says exactly. So they want x equals r, x equals 2, x equals 3. They want 3 of them. We're going to use this. Now, how do we do it? Open your calculator. Now, again, this whole, like the next 4 videos, the next rest of it is all about distribution. So we're going to use our distribution tab. See right there in blue? Distribution. Like I said, I like to read. So second, distribution. Now, the first thing you can see is normal. We're not going to use that right now. We're going to go to distribution toward the bottom. Now, it's really far on the bottom, so we just press up, a little shortcut. Look at that. And I saved like 5 seconds, right? So these two right there, A and B. Binomial PDF, again, only use that one that says exactly. And binomial CDF, and we'll talk about how to use that one in a second. Now for binomial PDF, hit enter. Hey, look what they want. They want trials, which is N, especially if you have it nice and updated. If you have like the 83, sorry, it follows the same pattern, NPR, but they're not gonna tell you. They're not gonna tell you like we do. This nice one, right? So number of trials is N, probability is P, and then R is X. Plug it in, you're done. So that's how you do binomial PDF. Just plug it in, you're done. Now binomial CDF, this works. This is a little more complicated because it only works at a specific time. It only works when they want at least or at most. But when I say a specific time, it only works for less than equal to. That's it. If you have greater than equal to anything else, you got to change it until you get to here. Has to be less than equal to. Has to be like this, right? Now CDF means cumulative frequency. So anytime you want to add like more than one, we use CDF because it's cumulative frequency. Right? That means adding up all the ones below it. So cumulative frequency. That's why it only has to be less than. Now, so we have to work with this a little bit. So if I gave you, keep in mind that we're doing binomial distribution is discrete. So that means your values are only ever, there's never going to be a decimal. It's always ever going to be 0, 1, 2, 3, 4, right? It's never like the in-between value. It's a discrete count. So keep that in mind. Because if I say something's like less than 3.5, that just means it's less than equal to 3. Right? If I say something's greater than 2.1, that means it's greater equal to 3. Because it's no in-betweens. That'll make more sense when we start doing more of these. So let's look at this, because this part's super important. If you could get this, you're gonna be fine. Binomial's gonna be easy. When people have problems, it's this right here. We're trying to do all these. So look at most 3. Now remember, I always like to think about like food. If I want at most 3 cookies, I'm like, okay, 3 is my max. So at most 3 is X is less than equal to 3. And that's exactly what I want. Ding ding, like that's the way you want it, right? So this one's just you put in your calculator, binomial CDF, and X is less than equal to 3. I'll show you how that looks like right now in your calculator. Right, if I go back to distribution, again, I like to read. Go to the top. Now we're going to use CDF because it's at least or at most. That's when you use CDF, right? PDF is only when it wants exact, a certain number. If you click enter, it's pretty much the same thing. Oops, let me clear that. It's a mistake. It's the exact same process. It's going to do the work for you, though. Now, again, this is the exact way you want to put it in there. I'll just plug in whatever I want for trials, for P. You don't change a thing. But again, it has to be in the right setup, which is this. Now let's look at the next one. The next one's a little tougher. Less than 3. So this is where I'm gonna start losing people. Less than 3 is this, like I said, is less than 3. That is not the right setup. Right? I need to be less than equal to, and that's not less than equal to 3. That's not what I have here. I have less than 3. Now go back to here. If you're less than 3, what does that mean? Well, it means remember, because you can't go in between values. There's no 2.5. If you're less than 3, that means you're less than equal to 2. So again, if you want less than, the way it works here is you go down a level. This is the same thing as saying X is less than equal to 2. And that's what you put in your calculator. Binomial CDF, X is less than equal to 2. Again, because I cannot stress enough, it has to be less than or equal to. That's what we want. That's the whole goal. We want this thing right here. Right, and right here it had less than 3. You got to think, okay, it can only be numbers. So if it's less than 3, you have to go down a level. X is less than 2. And that's what you put in your calculator. Again, we're going to do some examples, but just keep that in mind. And this goes to the next one. More than 3. Now, this is, if you're still here, this is going to get a little tougher. More than 3, right? Just think about it. Okay, that's straightforward. X is more than 3. Now, how would I do if this was here? It's like, oh, more than 3. That means X equals 4. That would work. If I said, but what if there's more? What if there's like 5? Then you have to go like 3. You have to go 4 plus 5. Right? It could be a lot of them. You have to keep on adding up. So instead, what we do is this. This is going the wrong direction. The way you flip it is you do the complement. So you're going to do this instead. You go 1 minus, because you do the complement, the opposite of that. Now think about this logically. Right? This is like an open circle going this way. right? Greater than. What's the opposite of that? Well, it should be a closed circle going that way. So this is going to be 1 minus x is less than equal to 3. Right? This, again, let me draw a little number line here. That was supposed to be a straight line. Here's 3. We had this. I want the opposite. I want less than. So you do 1 minus this thing, which is closed circle that way. Right? So if we're trying to figure out what this is, and we can't do, we can only do less than. You do 1 minus this thing, and that'll give us what we want. So this is what we'll put in our calculator. Do one in your calculator, plug 1 minus binomial CDF x is less than equal to 3. Again, we'll do some examples, but this is the general idea. Like, if you can understand this concept, you're going to be set. And we'll do some more examples to help you, but this is so important. This is the only part that people get that ties people up in binomial. And our last one before we do some examples, at most 3. So again, this thing about like food, at most 3 cookies. Well, we did that. Sorry, I meant to put at least 3. Sorry about that. It's like, wait, we just did that one. At least 3. Right, so at least 3 cookies. I want at least 3 of them. So 3 is at least. So you write that like this. X is greater than or equal to 3. Now, we have a problem here. It's pointing in the wrong direction. I need it to be less than. So we'll do the same trick we did last time. We'll do 1 minus. So it's pointing in the wrong direction, so I got to fix it. Again, we only want less than. That's all we're looking for. So you do 1 minus less than. Now let's talk about the same thing we did before. What does this look like? It's going that way. The complement should be an open circle going this way. Right? In general, guys, when you do 1 minus, I don't understand why people have such a hard time with this. It's greater than. So what's opposite? Less than, add the line. In this case, you have a line. When you do 1 minus, you lose the line. That's what's going on. Right? Once you do the complement, you lose what you have. If you had the line, you lose it. If you didn't have it, you gain it back. Like, that's just the general idea. Now, this part I understand. And you're like, okay, good, I'm here. Not done yet. Remember? I can't do less than. I need less than equal to. So just like before, we got to go down a level. So I'm not done yet. You got to go x is 1 minus x is less than equal to 2. And then that's what I put in my calculator. So take a moment, take that all in, because we're going to do some examples, hopefully make it a little easier. But this is the crux of it. If you could figure out, oh, at most 3, golden, plug it in. Less than 3, oh, I can't have less than, I have to have less than equal, jump down a level, done. Anytime it's pointing the wrong direction, right, it's pointing the wrong direction, do 1 minus. Now, when you do 1 minus, if you didn't have a line, you gain the line, so you're set, right? You want the line. If you had it, when you did 1 minus, you lost it, so now you got to go down a level, right? So general rule is, if you don't have a line, then you have to go down a level. If you're pointing the wrong direction, well, actually, this goes first, sorry. If you're pointing the wrong direction, do 1 minus, right? That flips it. And then, if you're missing a line, go down a level. So I know there's a lot to kick in, but we got to prosper forward and do some examples, which hopefully make it a little easier. So let's go back to Hugh here. Apparently Trump supporter Hugh. When rifle shooter Hugh fires a shot, he hits the target 80% of the time. If Hugh fires 4 shots at the target, determine the probability that he has hit the target 3 times. Yada yada. So let's do some first. So first, right, it is binomial. Remember, with binomial, you need 3 things. You need n, you need r, and you need p. You need the total number of shots he's taking. You need the ones that we want. And we need the probability. Now, this one's probably not going to change. P and n are probably not going to change based on what we're doing. Right? So he hits the target 80 times. That's your probability. 80% of the time he hits it. He takes 4 shots total. So that's your n. Only taking 4 shots. And the problem we're doing here, hits the target 3 times. That's our r. R is 3. Now notice how this one says hits the target 3 times. All we want is the target. He hits it 3 times or exactly 3 times. That's binomial PDF. Right, so binomial PDF, we have all our stuff. X equals 3, that's all we're looking for. So how do we do this? Well, we get to our calculator. Let me go back to the home screen real quick. Go to distribution. Go up to binomial PDF, right, because we only want it exactly. Trials is 4. Probability is 0.8. And we want r equals 3. Hit enter, hit paste, hit enter again. And remember, we want 3 sig figs. So 0.4096, and now it went away, but I'll get it back right now, 0.410. right? Right now, both of them will be fine, but that's what we're going to want. Right, that's how you do it. Hit exactly 2 times, just plug it in, get your answer. Now let's look at the next one. It's a little tougher. Hit the target at least 2 times. At least 2. So first step is knowing how to write that. At least 2. So I want at least 2 cookies. So x is greater than or equal to 2. We have a problem here. Well, first, it's a CDF problem, right? It's not exactly, so it's CDF. But our bigger problem is it's pointing the wrong direction. Remember, when it points the wrong direction, I got to flip it. So first thing we do is going to go 1 minus x is less than. Now, look, notice I had a line. I lose a line, 2. Now, again, I can't have that. It has to be less than or equal to. So I got to jump down 1. So 1 minus binomial CDF x is less than or equal to 1. That's how we're going to do this one. And that's the work you were showing in your paper too. Right? You go, okay, I got to flip it. So it's 1 minus x is less than 2. And then now, since it's only less than, I got to go down 1. How to put into my calculator? Well, the same idea. Second distribution, go up because it's faster, more efficient. Then we go here. We have 4 trials. It's 0.8. And then 1 now, right? 1 until we figured it out. Other than that, you do the same way. And now I should have actually done 1 minus to start off with, but it's fine. I'm going to do this. Don't forget to do 1 minus like I almost did. So it's 1 minus that answer, actually. And it's 0.97. So there's a 97.3% chance of hitting the target at least 2 times. 0.973. So let's move on. Hit the target at most once. Right, so again, it's at most or at least. I told you it's a CDF. That's probably the one you're going to use the most. And just think about it, right? At most once. So x is less than or equal to 1, right? 1's the most. Hey, that's what I want. I want less than or equal to. So this is binomial CDF. It's done. You don't have to do any work. It's less than. It has an equal to sign. You're golden. Just plug it in. So we're going to go back to second distribution. Go up to CDF. Good thing about the calculator, it's going to save a lot of that info for us. Right, boom, boom. I don't have to do anything. Just plug it in. It's all there. And 0.027. I hate when it does that to me. Okay, good. I had a shock checked. Next one. Here's a target less than 3 times. So again, just write it. So less than 3. Right? Look what the problem is. Is there a problem? Right? There's no line underneath it. So you got to go down 1. X is less than 2, or less than or equal to 2, sorry. Right? Again, if it's pointing the wrong direction, it's a big problem. You got to fix it by doing 1 minus. But if it doesn't have a line underneath it, you got to go down 1. Now I can put that in my calculator. Again, CDF, it's always CDF unless it's like exactly. So binomial CDF, just put that in our calculator. So second distribution, go up to P, we're doing CDF. Right, so 4 trials, so 80%. Now I want 2. Hit enter, hit paste, get my answer. 0.181, I believe it was. A few more. Hit the target more than 1 time. Right? More than 1 time, again, let's rewrite it. X is greater than 1. Now look at the problem. Pointing the wrong direction. Got to fix that. Again, if it's pointing the wrong direction, that's the bigger fix. They do 1 minus. So let's do that. 1 minus x. Now remember how we do this. It does not have a line, so I got to gain the line back. Hey, that's set. It's less than or equal to. It's pointing the right direction. I just got to plug this in my calculator. Now, but don't forget it's binomial CDF, right? So when I plug this in my calculator, I'm going to try to do the 1 minus first this time. So 1 minus, I have to do that. Second distribution. Go to binomial CDF, right? Because it's not exactly. All that stuff saved. That's still that. I want 1 this time. We're doing less than or equal to 1. What's the odds he hits less? What's the odds he hits that? And I get 0.973. Right? That's he hits more than 1 target. The odds he hits more than 1 target is the same thing as hitting at least 2 targets. Right? That's kind of the idea of moving it left, right. If you could get that down, these problems are easy. They're like 3 points. Actually, I'm not done. Find the expected number of times Hugh hits the target, right? So expected number, right? That's the same thing as saying the average number, the mean. Expected, same thing as the mean or the average. So that's just Or does big O E in the formula sheet? NP. Right, well, you already have those two. N is 4, P is 0.8. We'll multiply those two together, and you get 3.2. Right? And that's kind of the general idea. It's like all the questions they ask. I mean, they could ask, what's the standard deviation, what's the variance? Variance, you have a formula for it, and if you want standard deviation, just square root it, because variance is bigger. But other than that, that's like everything you're going to see. So let's move on to a few more examples, just to make sure we really hit this home. So look at this one. 72% of the union members are in favor of a certain change to their conditions of employment. A random sample of 5 members is taken. So already, there's a couple things I know. 72%, that's my probability, 0.72. You're taking a sample of 5 members, that's my n equals 5. Right, so I'm just going to find out what r is for each problem, and then just plug it in. Look at the first question. A, probably that 3 members are in favor of change. So notice that's only 3 members, not at least 3 at most 3. That's this binomial PDF. Binomial PDF, plug in x equals 3, and you get your answer. I'm not going to bore you by actually plugging it in. B, probably that at least 3 members, right? So now at least, just write it. I want at least 3 cookies. So there you go. Right? Now again, notice that one? Pointing in the wrong direction. That's right. You got to flip it. Right? It's pointing in the wrong direction, so we got to flip it. 1 minus x. Now again, notice it has a line, so we're going to lose a line. Less than 3. That's bad because I need a line to do it. So you got to jump down 1. 1 minus binomial CDF, right? Anytime it's less than or greater than CDF, x is less than or equal to 2. That's how you would do B. C, the expected number of members. Now again, expected number is the same thing as saying mean. Look at your formula sheet. It's right there for binomial. Expected number is just this. And that's what they gave us. So you have 5 times 0.72. It's bugging me right now. Just notice it doesn't have a point. And then you get your answer. Right? So it could go that fast. If you understand what it means, you know how to switch this, these things are easy. With that in mind, let's race through these next 2 real quick. I'll try to give you a little diversity in problems. 5% of electric light bulbs are defective at manufacture. If 6 bulbs are tested at random from each one replaced, notice independent before it's next chosen, determine the probability. So again, notice what we have. 5% are defective, so probably 0.05. I probably should check that first, because they might say how many are good, and then it'll be 0.95. But they're asking how many are defective, so I'm good, right? Probably defective, 0.05, that's what I'm looking for, I'm good. 6 bulbs are being tested, so n equals 6. Right, now I just gotta find my r. First they want 2 are defective. Remember, that's this 2, just exactly, that's binomial PDF. You're just gonna go x equals 2. Plug that stuff in. At least 1, again I want at least 1 cookie. So x is greater than or equal to 1 or more. That'll satisfy me. Right, and then notice, oh, it's pointing in the wrong direction. I gotta fix it. When it's pointing in the wrong direction, you do 1 minus. Right, it had a line, so now you lose a line. And now you're like, oh, I gotta go 1 lower. So 1 minus x is less than or equal to 0. Put that in your calculator. Make sure you're under CDF, because it is greater than or less than, and you're set. Now, sometimes it might try to be a little tricky, like this one. In a multiple choice test, there are 10 questions. Each question has 5 choices, one of which is correct. If 70% is a pass mark, and Raj, who knows absolutely nothing about the test, that's all my students, guesses each answer at random, determine the probability that he will pass. So a couple things here to try and mess with you. So first, there are 10 questions. So okay, that is my n, 10 questions. Each question has 5 choices. That's not my r. One of which is correct. That's actually your probability, right? You're guessing, randomly guessing. You have no idea. You have 1 is correct. You have a 1 in 5 chance of getting it correct. Your p could be a fraction. That's all good. It's like a y, but it's a 1. If 70% is a pass mark, and Raj knows absolutely nothing about the test, what's probably he will pass? So here's the thing. So that's your pass mark. So you think, okay, pass is 7, right? Get 7 questions right. No, actually, that's a barely pass. He could pass by getting 7, or 8, or 9, or 10. So probability is actually that you get greater than or equal to 7, right? All those are passing. So you could do probability 7 plus probability 8 plus probability 9 plus probability 10. You could actually do that. You could do binomial PDF and do all those, then add them all up. That works. For the easier route, if I'm trying to find that, let's point in the wrong direction. Do 1 minus, right? x now has a line, so I'm going to lose it. 7, which means I got to go down 1. 1 minus binomial CDF. X is less than equal to 6. So you can do it that way, or if you want, you could just do binomial PDF of 7 plus 8 plus 9 plus 10. But plug that in, you get your answer. Okay, last few examples, then we get out of here. An infectious flu virus is spreading through a school. The probability that a random selected student has the flu next week is 0.3. So 0.3 is probably have a school. So my guess is P is going to be 0.3. Mr. C has a class of 25 students. Calculate probably that 2 or more students have the flu next week. Okay, so A1, right? We have our P is 0.3. His class has 25 students, and he wants 2 or more. So X is greater than 2. X is greater than equal to 2, right? Because 2 or more, so greater than equal to 2. Oh, that's ugly. There we go. Redo myself. So look, so notice again, greater than equal to, so it's CDF, right? And I have this pointing in the wrong direction, right? So they go 1 minus X is, you have the line, you're going to lose it, 2, which means I got to go 1 lower. So 1 minus binomial CDF of X is less than equal to 1. Right, so that's the answer to A. Let's look at B. If more than 20% of students have the flu next week, a class test will have to be canceled. What's probably the test will be canceled? So first, let's figure out what 20% of the class is, right? You have a calculator. So 0.2 times students in my class, his class. You get about 5 students. So they say if more than 5 students have a flu, the class is canceled. So it's the exact same question, right? Or it's a very similar question, not the exact same. Right? It's saying, okay, all this is the same, but now more than 5 means your class is canceled. Now, it didn't say more greater than equal to or at least 20%. It says more than 20%. So if more than 5 people are sick, class is canceled. So now we have this again pointing the wrong direction, so you have to flip it. 1 minus. Now this time it didn't have the line, so you gain the line. And there you go. You put that into your calculator under binomial CDF. That's what that says. You get the answer. And the last one here, we'll still have 3 more to go, but last one here. If the school has 350 students, find the expected number. Expected number, that's easy. That's just NP, right? It's in your formula sheet under binomial. So, N is 350 now in this case, because now they're saying 350 students. They have 350 students, and P is still the same, 0.3. Multiply that together, get your answer. Next one's a little weirder, so let's talk about this one. If a fair coin is tossed 200 times, find the probability that between 90 and 110 inclusive heads turn up. So that's the part that I want to talk about. Because this part's still easy. 200 times, that's your N, not your P, it's your N, right? 200. P, it's a fair coin. They say that because they want you to know it's the same probability either way. So probability is 1/2 or 0.5. Now here it says between 90 and 110 inclusive. Now the way we do that is basically we're going to do this. We're going to do binomial CDF, because you add up all the numbers between 0 and 110, of X is less than or equal to 110, minus binomial CDF. Now here's the thing. I want everything from 110. This is 110. If I subtract 90, I'm going to lose 90. I want to include 90, so I said it's inclusive. So what you do is you go 1 lower. So you go 1 lower, right? So again, so that would be X is less than equal to 89. Right? Because if you had 90 there, then you're losing 90, and I want to include 90. So 110 minus 89. That way 90 is still in the numbers I'm counting. So that's why this one's a little funky. If you plug that in, you get your answer. I think it's 0.863, I believe. Check me on that. But that's the way. So anytime I say inclusive, it's a little weird. It's going to be this one minus that one. If they say inclusive, they want to keep the 90 in, so you can't subtract it off. You have to go 1 lower, 89. Okay, one final one. So we haven't actually talked about variance, how to use a variance and standard deviation, so I want to do an example of that. So right here, and I should probably just add one to earlier, but this will work too. 5% of a batch of batteries are defective. A random sample of 80 batteries is taken with replacement. Find the mean standard deviation of the number of defective batteries in the sample. So again, for me, these are like, oh, they're talking about 5%, they're talking about total sample. I see this and I go automatically go binomial. This is a binomial question. They give me some percentage, they give me a random sample, it's binomial. right? This is going to be my probability, which is 0.05. This is my n, 80. Right? So now for this, they want the mean. That's this right here. So that part's easy. The mean is expected value, right? It's the mean expected value, n times p, which in this case is going to be 0.05 times 8, which is 0.4. Now I want the standard deviation. There's not a standard deviation formula on here, but you got to remember standard deviation and variance are linked, right? This one's bigger. So this is the only time you use this variance formula. It's only in binomial. Again, I cannot stress this enough. Any other question, you can't use this formula. Only works under binomial distribution. That's why they're kind of connected in your formula sheet. So in this case, I could use the variance, which is just np times 1 minus p. So in this case, that's going to be n is 8. It's kind of flip kind of right there. Probability is 0.05. And then 1 minus 0.05 is 0.95. Put that into the calculator. So 8 times 0.05 times 0.95. And you're going to get 0.38. Now again, I'm not done yet. That's my variance. I want standard deviation. Remember, all you have to remember is that variance is bigger. So this is a bigger one. So I want the smaller one. So I got to square root it. So to get my standard deviation, I square root that. Use your calculator, don't be a hero. And you get the square root of the answer, square root. You can just put answer or highlight it. Hit enter, and you get 0.616. And that's how you find standard deviation and variance using binomial. And that's it for this video.